My name is Ramni, and I will start off with today's presentation. Let me start by sharing off my screen. Can everyone see my screen?
Yeah.
Okay, so Docker is a tool that allows developers, sysadmins, etc., to easily deploy their applications in a sandbox to run on your computer or any operating system. The key benefit of Docker is that it allows users to package an application with all of its dependencies into a standardized unit for your development. Unlike virtual machines, containers do not have high overhead and hence enable more efficient usage of the underlying system and resources. It includes everything needed to run your application. For example, your code, runtime, system tools, system libraries, and settings. It's all packaged in your environment. Basically, Docker is lightweight, reusable, and portable. We can begin by understanding a basic architecture of Docker containers. Let's say you have an application that you want to run, and so the sandbox or the loosely isolated environment where you want to run your application is called a Docker container. This container or a runnable instance can be generated from a template, which is called a Docker image. And this template or image can be created through a text file that contains a bunch of instructions. Let's look at a visual representation of the same. To repeat, a Docker file is a text file with instructions. It creates a read only template called a Docker image. And a Docker image is used to create multiple runnable instances, the Docker containers. You can create one or as many as you want from that one image. Let's dive a little deeper into Docker files. This is an example of what a Docker file looks like. Don't worry too much about what it means just yet. We are going to go through it line by line. Every Docker container starts with a simple text file, the Docker file, containing instructions for how to build your template or image. Dockerfile automates this process of image creation. It's essentially a list of command line instructions that are executed in order to assemble the image. The list of commands, Docker commands that you use in this Docker file is huge, but it's standardized. Docker operations work the same regardless of contents, infrastructure, or the environment variables. Please note this Docker file can also be seen on the JAWS document docs website. Let's start with the first line. From. The from statement starts out with the base operating system Ubuntu 22.04. Valid Docker file will always start with the from. You can choose what operating system you want to start with, whether it's Ubuntu, Alpine, CentOS, anything that you want to start with. You can choose that, and every instruction that comes after the from instruction will be executed and assembled inside this base. Next up, we have our first run command. Run command shown in this slide executes commands which updates the package lists. That's the apt-get update, installs the libraries that we need. In this example, we have wget and bzip2, and cleans the apt cache. Please note here that update, install, and cleanup are all combined in a single run instruction. Why it's such a good idea to do this? We'll go over it a little later. To make new software easier to run, you can use the env instruction to update the path environment variables for the software your container installs. The env, the env instruction, is also useful for providing required environment variables specific to services you wish to containerize. Lastly, env can also be used to set commonly used version numbers so that version bumps are easier to maintain. You can put version number as 1.0.1. You can use it as you name it a string, anything you want to use to version your Dockers. You can do that through env. In this slide, we are setting the installation path for Miniconda as an environment variable. Next up, in the second run command of a Docker file, this run command basically runs the wget that you installed above. It downloads the install script for Miniconda, runs the install script, and then deletes the install script. Again, all of these three things are in the same instruction, and it's a good practice to always update, install, and cleanup in one instruction. Why we'll look at it later. The final run command installs required libraries through conda install, removes the cache files, package tarballs, and entire package cache through the conda cleanup command. Again, everything in one instruction. There's another command called workdir. It sets the working directory for any run command, entry point, copy, add instructions that follow this command. So let's say you do workdir bbmap and then you do 2 runs, 1 command. All of those instructions will be executed in that bbmap directory. And then you can change it again to something you want, and the following instructions will be run in that new location. Finally, the copy command adds some files from your Docker host or the computer machine that you're running the Docker on, and it copies files from your host to the Docker container. This was a very basic run through of what those commands mean in that particular Docker file. Let's look let's dig just a little bit into what constitutes Docker images and containers.
Ramani, can you go back one? I wanted to make a point because you said correctly that when you set the environment variables or you set the workdir, it affects every command after that. But that's a little tricky because even though that's true, when you're running this, when you create a Docker container from this Docker file, that environment will apply to that container, and that's the main purpose of this setting the path or setting the workdir. Yeah.
Right.
Does that mean that the order in which the env is invoked doesn't matter? Or
correct. It doesn't matter. Yes, it doesn't matter.
And same with the workdir?
Correct.
Oh, I see. Okay, so that's different from what I suggested in the chat, that workdir bbmap is different from saying run cd bbmap.
Well, I think if you put the workdir, everything after the workdir assumes the command is being run in that workdir.
Right. Okay.
So it does affect the following commands. However, when you create a Docker container from this, it doesn't matter where that workdir was at the beginning or the end. It's still going to be. When you go into that container, you're going to go to /bbmap.
Right.
So that environment's going to get set no matter where it's
right. Okay.
in the Docker file. But it does affect the, if commands after the workdir depend on that position, that path, then yes, it matters.
So basically, let's say that after this workdir /bbmap, I say run echo hello world. And then to redirect that into hello world.txt. And then later on, if you want to look at the location of this hello world.txt, it will be inside the bbmap directory. Even so, all the commands, not all but these commands, run command, entry point, copy, add, these instructions will be run in that specified location.
Okay. And so if you want to do a different location after that, then later, then you would have to do another workdir.
Yes.
Okay.
But if for some other reason you forget to include this line workdir, is there like a default? Like your
it's just slash for Docker. It's just slash.
Okay.
So a layer is a basic building block of a Docker image. Each layer represents a Dockerfile instruction. But only those instructions that modify the file system will create a layer. Basically, if you have to ask a question, what is a Docker image or container made up of? You can say the answer is layers. Each layer will constitute only of the changes made to its previous layer. You can think of a layer as a diff. So even if the changes are adding some files, removing them, or modifying them, all will create a new layer. That brings us to the final point about this introduction to layers, that layers are stacked. That means that any given layer is built on top of its previous or its parent layer. If it's confusing, it's okay. We'll look at it. We can explain it a little bit. All layers have IDs. These IDs are basically a digest, which is of the form algorithm:hex. The hex element is calculated by applying an algorithm to a layer's content. If the content changes, then the computed digest will also change. Some layers are read-only, some have tags, some are writable, some don't have tags. Before we look at which layers have what properties, let's revisit the Docker file and see it from a layer's perspective. The digests or the IDs have been shortened for readability in this presentation. Since the from instruction establishes a file system, this will create a layer. The size of this layer is about 77 megabytes. Ways to figure out what layer forms at what size will be discussed later. The run instruction installs libraries, thus again modifying the file system. So this too will create a layer of approximately 4 megabytes. This layer will basically only contain the differences. So it won't contain the base Ubuntu operating system. It will only contain what changes are there from its previous layer. The env instruction only modifies the metadata and does not touch the file system, so it will not create a layer. Similarly, similar to the previous run instruction, this one installs conda and it will create a layer. The cleanup command, now that you know what layers are, if imagine if you had two layers, one to install Miniconda and then a next one to clean up Miniconda. Even though you have cleaned it up, there will still be a layer which contains the entire Miniconda with all the cache files. So even if you did clean up, the image size will not reduce. So in order for the cleanup to be effective, you need to combine the cleanup with the install in one command. This is the largest layer up till now.
And can I interrupt you?
Yes.
And that goes with apt update. So they always say you do apt-get update on the same line that you do the install for the same reason, because what apt update does, it updates the apt database on your computer to the latest versions that are available. And so it updates all the versions of the packages that you've previously installed using apt. And if you did that if you did apt update and then another run command and installed something, and when you say, you install wget or bzip without any tag or version, it's automatically trying to install the latest version. So if you did it on a separate line, it wouldn't necessarily update with it wouldn't necessarily install the latest version, because the second line is not seeing the database, the updated database. So you need to do it on one line.
Yeah, basically, let's say that you do run apt-get update, and let's say that this update has 1.0 as a version, as an overall version. Let's just say that, and then you do run apt-get install wget, and then you decide to change the Docker file and rebuild the Docker and add to the apt-get install and say, hey, I want to install bzip also. Then you rerun the Docker building, you rebuild the Docker. Then since the update command won't rerun because it's already there in the cache, and only the install will run, and you'll have an older version of the apt-get update.
Right. So yeah, I guess I was a little wrong the way I described it, but that's a better description.
Workday modifies the metadata, so it won't create a layer. And since you're adding a file to the system, the Docker system, you are creating a layer. So this again brings the point of cache and layers. The order of commands in a Docker file can have a very significant impact on ongoing build times. You should try to order commands so that the change between every single build are closer to the bottom. Basically, adding your code and similar steps should be held off until the end. Basically, like this image shows, put let's say you're developing your application and you are installing a bunch of libraries, setting up the environment, and then you're adding your own scripts. So you would place the stuff that you're developing at the bottom and the stuff that doesn't change frequently at the top. Because like we described before, Docker uses cache. So it'll check that, hey, is this layer already there in my computer? It's there, so no need to rebuild it. But if it notices that, hey, this file changed or this step is doing something different, then it'll rerun it. And it'll also rerun all the subsequent files, subsequent layers, sorry, not files, subsequent instructions. In the red box, as you can see, I put my copy script instruction as the second point, and then I'm installing all the apt-get libraries. So every time I make a change in script.sh, not only will the script.sh layer get rebuilt, also the libraries will get reinstalled every time. The correct way to do that is in the green box, where you are installing the libraries and then putting the script at the end, copy script at the end. So let's say you modify and just add a semicolon to your script, then the only thing that will get rebuilt is the last line, and all of the above layers will be reused from cache. This will help you to reduce the build times. By build times, I mean the time Docker takes to build your image from Dockerfile. Let's look at some of the Docker commands now. Please note that in order to run any of the Docker commands that I'll show from this slide forward, you need to have Docker installed on your machine. Can you see my screen?
Yeah.
So this is the Docker file that we just walked through, and you can see the same from Ubuntu, run apt-get libraries, and so on and so forth. And the script.sh that I'm copying is a simple one, bash script. It basically prints hello world. Let's just do Docker and see what it prints out. It prints out the basic usage. And then if you look at the list of commands, you can see there's a command called images, which lists images. Let's try that out. Docker images, and you see that it came up with nothing because I don't have anything on my computer. Let's try to build something with the build command, build an image from a Docker file because we already have a Docker file. The command does Docker build -t, which basically gives you the name of the image that you're trying to build. Ramnike is my username, which, let me pause this for a bit. So Ramnike is my username on that will be attached to the Docker image. bbmap_align is the image name. You separate, then you add a colon, and then you add 1.0.0 or any string which will be considered as a tag for the image. People normally use it to version their images. And then there's a dot, which basically means that consider the current directory to find the Docker file and other files. So once I enter this command, then it will use the Docker file and start building it. You can see some familiar things in the build process. You can see the from command that you wrote in the Docker file. You can see your run apt-get, and it's installing the libraries, installing Miniconda now. And this goes on for a while. I can fast forward it a little bit, and it's now installing the tools through Conda.
So while we're waiting, just to mention, there's a reason you named it Romanik, because that's your username for Docker Hub, which you're going to talk about later. So you could call it anything you want, but this naming strategy is what you would use when you want to upload and save your Docker image into Docker Hub. And Docker Hub is just, like a repository like GitLab for Dockers.
Yeah, and you can see some familiar words like exporting layers, and something you might notice is that most of the numbers are the layers that we talked about previously. So now let's see if it has built it by doing Docker images again. And now we see that we have a Docker image. It has a tag, it has an ID, and it has a size of about 1.36 GB. All the instructions that we just saw in the video are here in the slides for future reference, but I'll move on to the next demo. Now that you have now that you have built your Docker image, how do you run it? You use Docker run. So here, what I'm trying to do is just running some commands on my local machine to see what it outputs. And then I will be running the same things while running the Docker to see the difference, to make sure that I'm running Docker and not my local machine. So uname here outputs Darwin because I'm running it on my Mac. And if you do cat edc os releases, there's no such command, obviously. So now let's try to do Docker run. You're running this image that you just built, and any command that you want to run will go after this point. So let's try to supply uname -mrs, and this outputs Linux as we expected it to. Now let's try this one, etc os releases, and it shows Ubuntu 22.04, the distribution and version that we built the Docker image from. And if I try to run my script that I copied by doing bash script.sh, it'll print hello world like we expected it to. Now, what if you want to actually go inside the distribution or the sandbox and run some stuff over there? Then you simply supply a flag -i for interactive, and you can do an interactive session in the sandbox. By the way, when you're running it, when you do Docker run, it creates a container. So when I say sandbox, what I essentially mean is you're going inside the container now. So now you can see that when I do Docker run -it, I enter into bbmap directory. And because that is something that we set as the work dir, and I am root inside Docker. And when I do this cat os releases, os release, I can see it's Ubuntu 22.04. And it'll basically work like a virtual machine or your regular terminal. And you can see the file system like you expect it to. Again, for future reference, the commands are here in the slides. So before we go on to the next command, I want to briefly hit what container registries are. Like Jeff mentioned, Docker Hub is one of those. Container registries basically are a collection or catalogs of images. And Docker Hub is Docker's own official image resource where you can access more than 100,000 container images shared by software vendors, open source projects, and Docker's community of users, which is you. You can also use the service to host and manage your own private images. All Docker Hub users can share their images at will. They can also download base images from Docker file system to use as a starting point for your own projects. Apart from Docker Hub, there are many third-party registry services which are listed here for reference. And if organizations wish to host container images on their own on-premises infrastructure due to security or compliance concerns, they can do so through self-hosted registries. So in the next demo, we are going to try to push our image to Docker Hub. What it'll do is it'll basically store it on Docker Hub, and you can access it anytime through Docker Hub, or other people can access it unless it's private. we have the image in our system. Let's go to push an image or a repository to a registry. So when you try to do that, it will give you a denied requested access is denied because you have not logged in to Docker Hub yet or Docker yet. So in order to do a push, you need to log in first. And then if I retry, then it should successfully push the image to Docker Hub. As you can see, larger layers, the 990 and 290 megabytes, take longer time to push. So that's another consideration that you can keep in, that's another thing that you can keep in mind if you want shorter images or if you want shorter push and pull times. Just fast forward it a bit. It takes a nice 1 or 2 minutes to push it. For future reference, the commands are here on the in the presentation. Now, once you've pushed it, and let's say I switch computers or I am on some different node and I want to get the image, or I want to download someone else's image and run it on my computer, then I would use a command called docker pull.
Can I interrupt you again?
Yes, please.
Can you open up a browser window and go to Docker Hub just to show that it's there? It might be useful to see where it actually went.
Okay.
Because it's useful to manage your images and see what you have through the Docker Hub website.
Is this a private or public image?
It's public.
So if it's
By
public,
default.
you don't need to log in.
Okay, there you go. So
You don't need to log in. Well, to pull, I think you still need to log in to pull
Oh, okay.
through the command line.
so here's my
Oh,
home.
no, I'm sorry. No, to push you do, but not to pull. Yeah.
Good point. Yeah.
You don't need to have an account to use a Docker
Yeah,
container.
anyone can use
Yeah.
your
Image, yeah, unless it's private.
Yeah.
So this is the Docker Hub page for this image.
and that's why you name it Romanik / something, because it's under your username space.
Yeah, that's my username.
And then the name is BBMap, and then there's a tag which with all the versions. So
You can see that this is a tag, this is the digest or the ID that we just saw. And if you want to pull it, you can just copy this command. So if I go here, explore, and I can see different images that I can just pull and start from there. Or yeah, you can just search for different images. There are some couple accounts. I don't know if I mentioned them. There are a couple accounts like Evolve, BioInfo, and BioContainers, which are popularly used for bioinformatics related images. Let's try to, we can just quickly see how Evolve BioInfo. So Evolve BioInfo, for example, has a lot of images that you can use, like SAM tools, or if you go here, and if you just do if you just look at this and copy this, and if you paste it on your command line, you'll have that image in your computer.
So before you even create a Docker image, you would want to do a search and see what's out there. Maybe you find one called SAMtools that has 90% of what you want. You could use that as the starting point in your from statement, and you could just add what you want on top of that, and that would be the smart way.
Yeah, so some of these are really well maintained. Anyways, so okay. So in order to test Docker pull, I used another command called system prune, which will basically remove all the repositories and all containers from my system, and so that I can actually test Docker pull. This will remove all containers, all networks, all images, all cache. And then if I see all the images that I had in my list are gone, and now let's try to do a Docker pull on the image that I pushed. And then it looks for it on Docker Hub. By default, Docker looks for images on Docker Hub. And if you do Docker images after it's done, after it's downloaded, you can see that it's there again. And here you can also see its ID. Jeff will talk about SHA IDs later on. And if you want to check if it's running properly after pulling it, you can do the same command that we saw earlier. And that's the uname, and it'll show you Linux. Some miscellaneous notes. Oops. Okay, so as we saw, a Docker image can be built from scratch through Docker files like we just saw, or you can directly pull an image from Docker Hub or from common repositories. And Docker containers are something that you run, are runnable instances. Basically, you generate them from running Docker images, and you can interact with them. And another important good point to remember is that they're transient. Once you exit a container, all the things that you did inside that sandbox will get lost. And let's look at a visual representation of the layers in the context of images and containers. Images are made up of read-only layers. You can see that they are stacked, and each layer corresponds to an instruction from the Docker file that we saw earlier, and the layers are only created from the instructions that modified the file system. You can see that the last instruction that modified the file system constitutes the topmost layer. When you run an image to form a container, basically when you do Docker run, a thin writable layer gets formed on top of this. When you create multiple containers, multiple writable layers get created. Let's say you open a terminal and you open 3 windows and you use the same image and you run Docker run 3 times in 3 windows. You're going to have 3 different layers, writable layers from the same image. Because each container has its own writable container layer and all changes are stored in this layer, multiple containers can share access to the same underlying image and yet have their own data state. This is a summary of what we just saw. And once you exit your container, this thin writable layer gets deleted and all the changes made inside that layer will get lost. Now, let's quickly look at another command, Docker history, and it will also kind of summarize stuff from layers. When we do Docker, let's do Docker image, and we get the image ID, the C816. And when we do Docker history and paste that image ID, we can see the history for that particular image. You can see a bunch of steps and you can see its size. You can see some steps have 0 bytes and some do not. And the ones that have 0 bytes do not create layers. And you can, so if in the future you want to see which layer has the largest size or what's contributing to my image size, then you can do Docker history and kind of get a feel for what you need to change and what you need to reduce or to enhance your performance. The missing lines in the Docker history output indicate that those steps were either built on another system or were built with BuildKit builder, but you don't need to worry about that. They're safe to ignore since they do not point to any sort of an error. Let's look at another command called docker inspect. If you want a summary of information on your image, you can do docker inspect and plug in the image ID that you want to look at. As you can see, it will give you a complete digest ID. And if you go further down, you can see the environment variables that you set in your Docker file. You can also see the working directory that you set. And you can see its size. And finally, you can see all the layers that were created. So why use layers at all? Layers are used to save on computational effort and on bandwidth. Basically, let's say you have a similar Docker image, or you are developing and you pushed your image to Docker Hub, and the only change you want to pull is some small file or some 100 megabytes or something, then you can simply do a pull and all it'll download is the latest layer and not the entire thing all over again. This saves a lot of time and bandwidth, and you can skip unnecessary steps in your builds as well. If I were to do Docker build again and there were no changes or there were many just minor changes, it'll happen very quickly and it'll not take 2 minutes or 3 minutes to do the same thing. Just the changes will be downloaded. Let's look at best practices. So as we mentioned previously, you should run apt-get update and apt-get install in the same command to avoid breaking your Docker world and to avoid version inconsistencies. Remember to use the Y flag because when it runs, when you're installing, it's not interactive anymore. And if you need to press yes for anything, this will automatically do that. When you issue a Docker build command, the working directory that you're in is called the build context. By default, the Docker file is assumed to be located here. Regardless of where Dockerfile actually lives, all recursive contents of files and directories in the current directory are sent to the Docker daemon as the build context. So let's say you have the current directory that you're in has Dockerfile and the files that you want to put in Docker, but you also have a bunch of data, about 2 GB or something in the same directory. And when you are trying to build Docker through Docker build command, and in the end, if you remember, you specify a dot, which means that look for Dockerfile here. It'll also send all the data files to the daemon, and that'll get added to your Docker size, inadvertently including files that are not necessary for building an image will result in a larger build context and a larger image size. This can increase the time to build the image, time to pull and push it, and the container runtime size. If your Docker file resides inside of a remote Git repository, then all the contents of the directory directly containing the Docker file will be added to the image size. So you should consider, when you're building your Docker file, you should consider what your build context is, what is there in your current working directory, and if you should use Docker ignore file to instruct the Docker daemon to ignore certain directories and files. You should also avoid storing application data, which is similar to what I said, and you should use the volume flag instead. Jeff will um, talk on that little later. Do not add unnecessary content. Consider building your own base image. Base images are the lowest level images that other Docker images will build upon. Most often, these are based on minimal installs of Linux distributions like Ubuntu, Fedora, CentOS, but they can also be much smaller, containing a single statically compiled binary. For most people, using the official base images for their favorite distribution or a tool is a great option. Another would be to get the image size down substantially. For example, let's look at this Docker file, which is a slimmed down version of the Docker file that we just saw. It uses Alpine distribution. It's a Linux distribution, and this Linux distribution is only 5 megabytes in size and has access to a package repository. This makes for a great image base for utilities and even production applications. But the negative or a con for this is that you have to manually install a bunch of softwares and tools and libraries for this. So once you have Leaner base, you add libraries, you install BBMap, install SAMtools, and add your scripts. The image size comes out to be about 560 MB, which is about half of the size that we previously saw. And if you see, the main thing that we eliminated is Conda, and you and install these softwares and libraries manually. Since sometimes Conda also installs stuff that you don't necessarily need, and that can increase your image size. So that is something that you can consider if you are worried about the size of your Docker image, or if you're worried about the pull and push times, you can take a look at that. And if you are interested in increasing your performance even further, you should definitely take a look at what multi-stage builds are using this link in the slides. To sum it up, so why use Docker and what are the benefits of using Docker? Unlike virtual machines, Docker containers don't carry the payload of an entire operating system. They include only the operating system processes and dependencies necessary to execute your code. They make better use of hardware capacity and have faster startup times. Docker containers contain their own operating system, so they will run on any platform, even Windows. Containers are lightweight and contain everything needed to run the application. So you do not need to rely on what is currently installed on your machine. It's highly portable. Docker containers can run on your local laptop, on physical or virtual machines, on cloud providers, or in a mixture of environments. You can also scale up or tear down as you need in real time because of its portability and lightweight nature. It's versioned, so you can track versions, you can roll back to your previous versions, and because of its structure and how it's built, you can trace who built a version and how and what were the changes. You can easily distribute it as a single tar image file or put on Docker Hub so it can be pulled, and a large number of applications can be hosted on the same machine. It can even upload only the deltas between an existing version and a new one. You can easily share containers while you work and be sure that everyone you share with gets the same container that works in the same way. So what are Docker alternatives? One is Shifter. So Shifter was developed for HPC systems so that users can run their Docker containers on HP systems securely and efficiently. Since Docker basically runs as root, it becomes a risk to run things on big HPC systems. So Shifter was developed as a solution for that. It strips out all requirements of root so that you can run everything as current user. It works with Docker images. You can pull and convert Docker image, and Docker does not need to be installed. It's transparent to host file system and does not need a local daemon and works well with Slurm. There's another software called Singularity. It was developed for users who are looking to run their containers anywhere. It works with Docker images. And you can also, it basically you can import Docker images as base images. You can convert Docker images to Singularity images, and you can run Docker directly also. Base format for Singularity images is a single file. And that's the simplicity of it, that Singularity is a single file. So you can easily distribute that file, archive it, or share it. And you can run it as you can run it with user privileges, basically. It's efficient for parallel file systems. Now, Shifter and Singularity both run as user and not root. HPC systems use them for security reasons. And you cannot access folders with root access requirements. Basically, if in your Docker image you are working on anything which resides in root, for example, or bin, you won't be able to successfully run it through converting it via Shifter or Singularity. So it's important to make sure that your code in Docker will work with, your code in Docker will run as user. This guarantees that your Docker container will work with Singularity or Shifter on HPC systems. And you should add user in Docker so that you don't accidentally install or run something as a root user anyways. By default, Docker containers run as root, just to repeat myself. And in order to change the user from root to non-root, you can use the user command in Docker as shown in the slide. Even if you're not planning to use Shifter or Singularity, it's a good idea to do that, because root user is the same root user of the host machine or your own machine. This fact can enable hackers to perform various types of attacks on your application, and basically can make your container vulnerable. So it's always a good idea to use root only when necessary. I'll hand over to Jeff.
So yeah, I just wondered if you can add user to your Docker file anywhere, or do you need to wait until you finish the root installation and stuff? Sometimes you need root privileges, right? When you're building your Docker file.
I think so, yeah.
We're going to talk about a Docker file, the different commands in the Docker file. We're going to have to just kind of wing that one. And first, I'll just talk about what I have organized already. When you're creating a Docker file, usually you have a list of dependencies that you need to install. So then a little bit about what different ways of installing stuff. There's these package managers that you can use to install pretty much anything out there. But if you can't, if there is no package that someone built already for what you want, you may have to go to the source and do the make install and all that. But you first want to try one of these three things. And so the difference is that if you're on Alpine, let's say you create an image with Alpine, you're going to use the APK command. Otherwise, you're going to use apt-get. And of course, there's more flavors of starting images you can use. And there's probably more besides apt and apt-k, but these are the main ones you can use. So basically, this is probably the easiest way to install stuff. When you let's say you have a list of things here you want to install for your Docker image. So first thing you do, what I do is I just Google install wget, for instance, or install XAMTools and so forth. And so usually you'll see that there's a conda package already, or there's an apt-get package already. Another way, more organized way you can do it is each package manager has its own library. So if I went into this apt-get, for example, and then I could just say search for wget, then it finds an exact hit. And then I know that I can use the command apt-get space wget, and that would work. So I can also find them and bz2, and there's a lot of stuff here already. So that's the easiest thing. There's pip, which is good if you want to install Python, and then there's conda, and conda is cool because it will allow you to create an environment, and this is what we do in the example. We use conda to create an environment, and then we use the command again to install different things like bbtools and bbmap. You can even use pip install within that conda environment. So conda is both an environment and a package manager. Just like, I guess, pip is a package manager for Python, and the environment is called a virtual environment, or VNV. So conda and VNV are both kind of equivalent, but the difference is that conda can include any language, a package with any language, not just Python. So it's useful. However, it's kind of big. It takes a lot of space, but you can remove a lot of the junk once you're done building. And so if I search for bbtools and I Google it, bbtools install, it comes to DOE, JGI, and I see that to install it, it's actually a jar file. So all you have to do is you download it and you're done. You don't even need package manager. You don't need to make it, right? It's a jar, so it's done. It will work out of the box. And in my example, I'm using, for bbmap, I'm using conda to install, and I should probably show you. Yeah, here. So I'm installing bbmap with conda, but I don't need to. I could just install it using wget and put it into my user bin, and I'd be done. So after figuring out where these different dependencies come from, I install wget bz with apt-get, and then I have to actually install miniconda before I can use the conda command. So that's what all this is. Now I set the path to point to where miniconda installs all the tools. So now it's in my path, and so everything here is going to be in my path, right? So bbmap and XAMTools are both conda packages, so it's convenient to just install them both. Notice I have versions, and that's important if you want your Docker image to be reproducible. If I didn't have a version, then when you install it, it's going to install the latest version, and that may have conflicts with other things. So there's no guarantees. And one problem you have, a big problem actually you have when you're building these Docker files, is that you want your latest bbmap and your latest XAMTools actually has a conflict. So you may have to go and try and use an older version of one of these. And then the problem is conda doesn't have the older version, it doesn't have all the versions, right? Because all these package managing libraries depend on some good person to build the latest version and save it into the library. So then you may not have, so then if it doesn't exist in conda, a specific version, you're gonna have to go and maybe use apt-get, or some other way, maybe use pip or something, and you find the version you want. So there's some trial and error involved in getting the versions to play nice. So notice, yeah, we're copying the script. I'm going to talk about this again. So is there any questions about package managers? Okay, so I want to talk about, I think Ramani said that once you create a container and you quit out of it, everything that was generated inside that container disappears. And the caveat is if you mount a directory, like your local directory or your local machine, you mount your directory to the container, and as long as you add files to the mount point, you're not going to lose them, right? They're going to appear here. So any file that gets created on your desktop /desktop in your image will appear in my desktop. So that's sometimes, you run something and nothing appears, no results appear. So you wonder, what happened? And it's a lot of times it's because you didn't mount correctly. And I was going to do a quick demo, but I'm not sure. I don't think I need to because I have another demo that will illustrate this point. But if you built this image right here, and then you just created, you created any file under /desktop, then you would see, and then you quit the image, you would see that it appears on your in this desktop. But I don't think I need to do that. A quick thing about Shifter. Let's see, I'm gonna try and demo that. Core is working. So now I'm just logged on to Cori, and there's two commands. Shifter img has these three commands, subcommands. So Shifter image, this is kind of a management tool. It's not for running images or containers, but it's kind of more of a management. So images will give you everything that exists on Cori, and there's a lot because people will pull stuff down into Cori registry and they won't delete them. And I don't think there is a way to delete them. You have to ask Shane Cannon to delete stuff. So nothing ever gets deleted. But what's happening when you do a Shifter pull, and let's try, I'm sure this has already been pulled, but this is how you would pull one of your images. You do this, and it's actually going by default to Docker Hub, and it's putting it into the NERSC or Cori registry, which is the local version of Docker Hub. So now that's what you're seeing in here is the local version, but it doesn't matter to you, practically speaking. You just use Shifter, just like you would with Docker. So for instance, you could do, if I wanted to run that image, yeah, just do this. Okay, if you want to do it interactively, you don't add anything, any script, and it automatically goes interactively. And so now this is different from Docker. When you go interactively, you're not at root, but you're actually at home. Wherever you launch this command, that's where you're going to be. So it sort of automatically mounts your local directory, your current working directory. And it also mounts, I think, pretty much everything else on the file system. Not everything, but a lot of things. Like if I was to look at global DNA shared, that's there. So you have access to a lot of other mount points. So you don't need to use the mount, like in Docker, you have to use -- volume to mount stuff, right? And talk about that next. Oh yeah, so because everything's mounted, once you go in to here, you can develop in here. So if I touch some file, then I see that it gets created here. So you don't need to mount anything. I'm going to go into, I have this. So what I did was I cloned, I just made this repo for workshop demo stuff, and you have access to this. So for today's workshop, I have these 3 files. What I want to do is I want to run this script using the image or container created from that Docker file. And
Sorry, Jeff, just for reference, Jeff is referring to the slide 66. So all the commands, if you don't want to clone the repo, go to slide 6. Yeah, that one, exactly.
This is, so there's the video here you can play, or the same commands are just duplicated here. So I'm just going to go through these fast. And so the idea is, if you run this script, it basically fails because it's looking by default. If I don't give it any arguments, it's just looking for these tools in my path, but they don't exist. I need to run it inside of a container because I've installed these inside the container, right? And also, I'm going to add eventually these 2 arguments. It's because I want to create this. What the script will do is create an alignment of the FASTQ reads against the FASTA file. Okay, so now, maybe I'll do the video and just talk over it. So I cloned. So the scripts are not on my path. So I'm going to run this using the Docker image. And yeah, this is just the point I already said, that I installed these things, these BBMap and SAMTools in my path using the env command, and I've copied the script into the image. And lastly, the working dir is /bbmap. These will become relevant in the next steps. I'm going to run this with the Docker. I'll build it. So you don't want to, you don't want to build this without creating a Docker ignore file, because otherwise I'm going to be including the data in the Docker file inside of the image. But that doesn't mean you're going to see data in Docker file in your container. If you interactively went in there, you're not going to see them because I didn't copy those in. I did copy scripts, so you would see that there, right? Even though I didn't see them, they're still going to be part of the size. So I'm creating the Docker ignore, and then I run the build. Okay, now I run the script. And if I ran it with a /script, that's going to fail because /script doesn't exist inside the container, right? You want to make, you're trying to use the script that's inside the container. So I run that, and then I have different errors. Oh no, well, it says that the tools now exist in my path, but I still need to add the data. And the data exists under the data folder. There's FASTA and FASTQ. And so I'm going to add those two samples. Okay, it fails again because, again, data /sample, that path doesn't exist inside the container. So this is where it gets tricky. And when you have complicated containers and commands, and it gets confusing what's happening. So the best way around it is to interactively go into the container and get the script to work. And then you can use that same exact command outside of the container. Oh yeah, the other thing is you have to mount the data there. Okay, so even though I mounted the data, data /sample still doesn't exist. So now thoroughly confused, you go interactively. So now I'm inside and I see that the two files are there under /bbmap. You can see that my current working directory is /bbmap because that's what I set inside the Docker file. So if I wanted to get the script to work, I would just run bbmap. I would just run, let's see. I'll just run this command. Okay, now I just copy it. I go outside of the Docker container, and now I can just run it the way I was before, but with that same command. It should work. Okay. So are there any questions about that?
I have a question, actually.
Yeah. Okay, go ahead.
So maybe this is pretty naive. I was trying to kind of follow along with what you're doing. I cloned the repo and everything, and I'm getting a permission denied while trying to connect to a Docker daemon error when just trying to do Docker run or Docker build, for example. So just on Corey, and I'm not sure if that's
Corey?
expected or if that's unexpected or what. And I don't know if anybody else is having that issue or anything.
So Docker's not installed on Corey.
Okay, it's not installed on Corey at all.
Yeah, so that's a good point, because the only way to build containers is through your laptop, because that's where you have root access. You don't have root permissions on Corey or any HPC because they're trying to protect, you from hacking and destroying the whole system.
Sure,
So that's
fair.
why they've invented Shifter and Singularity. Those tools will allow you to run Docker images, but not as root. So you're safe. It's a compromise, but so yeah, you have to build on your own computer.
Okay.
So you got to install Docker. There was some information about documentation and how to create a Jira ticket if you have any issues. But this is mostly for if you're using JAWS. If you have just a check question about how to develop WDLs, you could use the JAWS channel, or you could just Slack us, any one of us, Danny or Jeff or Ramani. That's probably the best, most instant way. And then this is for your reference. And I think that's it.